Okay, good morning everyone. Welcome to lecture 22 of computing. This is the last lecture for the resource allocation problem. So in this problem, I'll tell you the algorithm. We already discussed two algorithms. One is Hygia algorithm. Second one is called as DPS algorithm by Nathani and its group. Third algorithm is ALTRA, which stands for Alert Time Based Resource Allocation. Prior to discussing the algorithm, we discussed various types of leases, right? In which I told you there is a token reservation. In token reservation, I gave you one example of the banking system. So once you reach to a particular bank, okay, based upon your operation, whatever you want to do, it is your deposit operation or withdrawal operation or a check issue operation, they are going to issue a token to you, right? You did not stand in the queue, okay? So you have to collect a token. Once your token time is coming, okay, token is display, then what you can do, you have to go to the corresponding counter and can do your operation that we have discussed, in which I told you three things. One is token issue time, next one is token alert time, right? Alert time is nothing but, suppose you require 1 hour before 5 p.m., so your alert time is 4 p.m., right? 5 p.m. minus 1 hour is equal to your 4 p.m. Okay, another is called as a token expiry time. Okay, if you will not solve at 4 p.m., as it will require 1 hour, then the token will be expired, right? So let us see how we are going to schedule using this alert time based resource allocation, right? So you can see here in this slide we have 7 leases with their arrival time, start time, deadline, period, notes, and alert time. How you are going to calculate alert time? You have seen previously in the Hygia algorithm, we are using the slack value, right? We are calculating the slack value. In case you require uh, rescheduling, okay, or swapping operation, before that what you are doing, you are calculating the slack value. And these leases are sorted according to the increase of the slack value in the Hygia algorithm. On the other hand, if you go for ALTRA algorithm, here you can see the alert time is nothing but deadline minus period. You can see in the first case, the deadline is 10:30 and the period is 40. So your alert time should be 9:50. What does it signifies? It signifies that if you will not start the first lease at 9:50, then you will violate the deadline. Okay. And prior to this alert time, if any leads got chance to execute work, then the alert time is updated. For example, assume that in this case 9 to 9:10, 10 minutes slot is vacant. So what we have to do, we have to update the alert time as 10, because out of 40 minutes, 10 minutes is already solved in between 9 to 9:10. So rest, that's why deadline minus period required, that is 30 minutes, you will get 10 a.m. Okay. So if it is not, okay, in between 9 to 9:50, you are bound to start at 9:50. Otherwise 40-minute period is going to serve before the deadline. Similarly, you see L2 case, L2 the deadline is 10:30, period is 30, so it is 10 a.m. L3 case, it is 10:40 minus 30, so it is 10:10. L4 case, 10:30 minus 40, like previous one, so you will get 9:50. L5 case, it is 11 minus 10, it is 10:50. Like that, you can calculate time. Why you are going for this alert time? So you have to keep record that at this point of time, the process, the release need to, otherwise the SLA will be violated, right? So let us see how it is doing, how it is performing the scheduling. I will come to this figure later. So let's do the theory part, then we'll discuss how it has accommodated these leases. Okay, here you can see the alert time of the leads are calculated. That is nothing but x is equal to deadline minus start time. So here you can see some comments. People are saying how you can subtract 1030 and 40. 1030 is in time format, 40 is there in a decimal format, right? This is a value, right? So you cannot subtract it. That's why what happened, the formula is nothing but 1030 minus 40, right? If you interpret it correctly, if you are not interpreting what it is saying, you have to subtract deadline minus start time. The deadline minus start time is nothing but your 90 minutes. Okay, 1030 minus 9, both are time format. That is nothing but format, right? So you can subtract these value. Once you are subtracting, you are getting the value as 90. Then in order to calculate the alert time, what you have to do? You have to write x is your 90 minus period. 90 minus period is 50. Okay, minus alpha. Alpha is nothing but your overhead time, because whenever you are taking a scheduling decision or whenever you are calculating something before assigning a leads to cloud resources, so maybe an overhead time, because calculation also takes time. It may be in the millisecond, it may be in the nanosecond, it may be in anything, but you have to consider this as a minus alpha, which we assume that it is 0, but in order to complete the model, you have to write minus alpha. Like operating system also, whenever we are discussing round robin algorithm, there is a concept of context switch. Context switch means you are moving from one process to another process. Moving from one process to another process always takes time. But for the simplicity of illustration, what we are doing, we are calculating or ignoring that value, or we are taking the value as 0. Right? That's why this alpha parameter is there. So if you calculate start line plus this x minus p, x minus is 90 minus your period is 40, then you have to go ahead of 50 minutes from the start time. Otherwise, the formula no need to write in there if you interpret it correctly. So you can write deadline minus period is nothing but our alert time. See, in this case, 1030 minus 9 they have calculated, the value is 90. 90 minus 40 is 50. So assuming that alpha, the overhead time is 0, you can say my alert time is 950. So what it is doing? First step of alert ALT array. First, it sort the leases in the ascending order of their start time. Come to this. If 7 leases are submitted to the cloud service provider, the very first is that you have to sort the leases according to their start time. Okay, you can see L1 to L4 is having start time, L5, L6 having the same start time, L7 has different start time. Okay, so based upon their arrival, what you have to do, you have to sort them according to their start time. Okay, because we have to give priority to the leads which came first. Second one, then it divides the whole set into groups. Out of these 7 leases, what you have to do, you have to go for group formation. How you are going to go form the group? For that, what you have to do, the leases with the same start time are kept in the same group. If you see this example, L1 to L4 is having the same start time, so they form a group called G1. L5, L6 is belongs to the same group, so they have same start time, so they belongs to the same group, that is group 2. L7 is alone make a group because its start time is different from other leases. This is the second step. Third step is next, it calculates the alert time of the leases. Once you form these groups, what you can apply the formula of alert time. Okay, and this alert time of the leases you have to apply in group. Like G1 is having a alert time, G2 is having a alert time, G3 is having a alert time. Okay, and after doing this group, what you have to do, allocate the leads such that the leads with earliest alert time is assigned first. Out of it, you see in group 1, L1, L2, L3, L4 is present in group 1, L5, L6 is present in the group 2, L7 is present in the group 3. Out of these four lineages, which one is having earliest alert time? You can say L1, L4 is having earliest alert time. Earliest means the nearby deadline, right? So this is 950 and 950. So there is a tie. Here there is a tie, right? If there can do, however, if there is a tie with the same alert value, then the lease with maximum node value, okay, that is with maximum number of node requirement is assigned first. Concept is same as your DPS algorithm. DPS algorithm also specifies that if you are unable to schedule the newly arrived releases, what you have to do, you have to go for the already assigned leases, right, and arrange them in the decreasing order of their number of nodes. Okay, for that if you can accommodate the newly arrived leases, then it is fine. Otherwise, you have to roll back your scheduling, right? So if there is a tie, like the tie you can see L1, L4 in the first group, L1, L4 is having the same alert time. As they have the same alert time, which one will come first? L4 will come first because L4 is having earliest deadline as well as number of nodes required for is 4, right? If there is a tie again, here it is 4, here is, let's say, instead of 1 it is 4, then you will follow the chronological order. Chronological means L1, right? Otherwise, you have to go through the number of nodes and act accordingly. This approach has two basic advantages if you compare with your Hygia algorithm as well as your Nathani Eaton or DPS algorithm. What is the advantages? It prevents the deadline of the leases, right? Violate the deadline in the previous two cases, but as here we have introduced the alert time, before that time, okay, or that particular time, you can alert to service provider, my lease need to start as soon as possible, otherwise you are going to violate the deadline. Or a software unit will work, remind the cloud service provider that you have to immediately start this lease in order to satisfy the service agreement. And second one is it utilizes the resource properly, right? Like in the previous case, you are haphazardly scheduling in the Hygia. On the DPA, you are making decreasing order of the nodes if and only if you cannot accommodate a lease. But before taking that decision, alert ALTRA is reordering the leases based upon the earliest alert time as well as the number of nodes. So you can see here the first four leases I have represented G1, next two is as a G2, the last one is as. So first lease is belongs to first group, first four leads, next two leads is second group, third one is your alone L7 is forming a group, that is group G3. Then it calculates the alert time of the leases. Alert time of leases you can calculate is given in here. I told you you can go D minus P or you can go for D minus ST. You can take the value as X and whatever value you are getting, X minus you have to add with the start time. Subjected to overhead also you can subtract, right? So there are three dimensions here. So if you see a particular link, see the L1. So L1 is forming means this group L1, L2, L4 is forming group 1, right? So we are decomposing their time into three different sets. One we call a start time to alert time. Next one is alert time to deadline. Third one is your start time to deadline. Start time to alert time means 950 is one set. Second one is alert time to deadline 950 to 1030 is one set. Next one is start time to deadline 9 to 1030 another group. Why we are making group? Because you have seen in the DPS algorithm they are also forming groups and they are comparing with each other. If a newly arrived lead is not able to accommodate, then what they have to do? They have to take the help of these sets in order to assign the leases to the cluster of resources. Subjected to the condition that the lease which is already accepted, it will be remain accepted after the rescheduling. So you can say between the alert time and start time, we are forming one group. Between the deadline and alert time, or alert time and deadline, we are forming another group. Within the start line to deadline, we are forming another group. The proposed thing with the swapping. So whenever a newly arrived lease is unable to in the system, what you have to do? You have to repeat this procedure. What is the procedure? The proposed scheme with swapping reschedule the leases by forming set. It is taking two different list set. One is start time to alert time to deadline. Like if you see L1 case, start time is 9, alert time is 9:50. Okay, it is forming the group from 9 to 9:50, and alert time to deadline means 9:50 to 10:30. And it is whether the intersection of these layers, these two sets, what you are forming, that is start time to alert time and alert time to deadline, you have to find the intersection. Why you are interested for intersection? We are interested for the intersection because if there is a lease which is present in the start time as well as alert time to deadline, the comparison is no more required. For example, last class I told you, suppose STALT is having three leases L1, L2, L3. Alert time to deadline is also having L1, L2, L3. So what you are doing? You are comparing L1, you are also comparing L2 with L2, L3 with L3. Although you are comparing L1 with L2 and L1 with L3, but there is a repetition. Swap L1 with L1, what is the result? The result is same. If you compare L2 to L2, what is the result? Same. So in order to avoid that, what we are doing, you are finding intersection of these two created sets. If the intersection is not empty, so what we want to make? We want to make intersection is empty. How we are doing? You have to write STLT is nothing but STLT minus alert time minus alert minus deadline. If you subtract that, then what will happen? Each lease of STLT is now compared with ALTD as there is no duplicate element. Okay, in the STLT set or ALTD set, there is no common element after doing this operation. Okay, so you can save your time in the swapping step. Okay, you can save your time in the swapping step. So the first remark, if you see here, if two leases is having M leases, assume that ST-ALT set is having M leases, ALT-D is having L leases. Then, but how many comparisons are there? ML? The total number of comparison is M into L. Each lease will be compared by L lease if swapping is possible, subjected to the condition that if they swap, then also they are not going to violate the deadline, then swapping can be done, right? So in that case, if you see the order of ML time is there, but if you go for this DPS algorithm, that if M leases are here or N leases are there, so almost if you see, if I can say the total number of leases in the worst case, if you take the number of elements present in the STLT is N, total number of leases that are present in the ALTD is also N. So if you do such comparison, the number of comparison is order of N square, okay, which is more than your order of ML, because ML guarantee that there is no common element in these two sets. But this second remark says there is a common element possible. In the worst case, all the elements that are present in the STLT set is there in the ALTD. So you can avoid it. Right? This is the main advantages of using this ALT array. What is the condition for swapping? We can perform the swap if the following two conditions are. First condition is the leases that are present in the STLT set has then ALTD. If they have less resources, then only allowed. Because if you take more resource, then it may happen that the in STLT may not meet the deadline. And interchange of STLT, ALTD, whatever leases you want to you are not violating line of the leases. The swapping will not violate this, so then otherwise, otherwise it is difficult. Just a minute. Okay. So what is the note here? If the newly arrived lease is not allocated after swapping, then it will roll back the residual. Okay. If it is not possible in these two steps, then what you can do? You can roll back rescheduling, right? So you will go to your previous particular slide. You're clear. Out of L1, L, which one to execute first? The earliest deadline, L1 and L4. L1, L4 is being earliest deadline. But out of them, high is taken by requested. So L4 I am assigning first. After that, I am assigning L1. Okay. Then earliest deadline is L3. So I am assigning L3 here, right? Sorry, yes, L2. Next is highest is L2, right? After L4 and L1, the next one is your L2 because it is having earliest alert time. So L2 I have assigned here. The last one in the group one is L3 is assigned, right? As there is no need of rescheduling, we are not going to forming the sets, right? After that, you can assign L5, L6. Out of L5, L6, which one is just alert time? The earliest deadline is L6. So L6 is given more priority in comparison to L5 because L5 has the deadline not the deadline is far away, right? It is not in the nearby, right? Similarly, in the L7 case, what you can do finally L7 is the single lease that are present in the group 3. So finally it is assigned. So this is the Gantt chart you can get if you are applying ALT array algorithm. Okay, how you can compare the performance of these leases? If you want to compare the performance of these leases, you have to take some parameter. Like in the student case, what we are doing, we are calculating SGPA, we are calculating CGPA, we are calculating let's say extracurricular activities. So based upon that, we are judging a particular student. Okay, we are calculating that whether the student is performing well in the semester or not. There are some parameters we have to check. Similarly, in this case, in order to check the performance of the three algorithms, that is IGR, DPS, and ALT array, you can take a set of performance metrics. First one is called as your accepted leads. Accepted leads means how many leads you have submitted and how many accommodated using a particular algorithm. That's why it is saying total number of accepted leases accepted in a data. We have given the data set with 11 elements, let's say 22 elements, let's say 33 or 44. Or in the previous case, you can see we have given 7 number of leases. Out of 7 leases, how many leases are accepted? That is called your accepted leads. Second one is called your rejected leads. Rejected leads is nothing but total number of leads minus accepted. Suppose out of 7 leads, 5 leads is accepted. So 2 leads is rejected. So rejected leads are the difference of total number of leads and accepted leads. Third one, leads insisting rescheduling. Very important. Don't be confused in next two term. It is very important. Leads insisting rescheduling. For example, L1, L2, L3 is already activated in the system. L4 is the new lease arrived to the system. When L4 is arrived to the system, there is no for L4. So what we are doing? We are calculating some process or we are invoking a process in order to reschedule L1, L2, L3 that are the leases that are already scheduled. Okay. So L4 is the lease that is insisted L1, L2, L3 to reschedule. That's why it is calculated as a least insisting rescheduling. So you have to calculate in a particular scheduling what is the total number of leases which are trying to reschedule other assigned leases. Okay. So it is insisting. It is insisting whether it is accepted or it, you will do the rollback, that we do not know. If you are rescheduling, then you will take the number in the fourth parameter, that is called as rescheduled leases. When L4 is coming, you are rescheduling L1, L2, L3 in order to accommodate L4. That lease you will count as a number of rescheduled. How many leases are rescheduled? Because for your L4. Okay, that's what it's saying. It is the total number of leases which are rescheduled to make space for new leases. Suppose I am trying to reschedule L1, L2, L3. Then out of L1, L2, two leases are rescheduled. Like L3, L1 is rescheduled, L2 is keeping constant or is there in the same position. So I can say total number of leases that are rescheduled for accommodating L4 is 2. That is L1 and L3. So there is a standard data there. I will see the data set with you people, right? So the data set consists of four different types of four number of data sets. One data set is having 11 leases, another data set is having 22 leases, another is 33, another is 44. Okay. Leases. Out of these four leases, what you can do? You have to run the three algorithms in order to take that which algorithm is performing better. And you have to take a four node cluster. In the four node cluster, you are going to assign 11 leases in the first data set, 22 leases in the second data set, 30 data set, 44 leases in the last data set. Right? So if you check their performance, this is not required. You can see ALTRA nothing but the number of accepted leads. If you see the number of accepted leads, right? 11, 22, 30, 44 is the four data sets. And if you see the accepted leads, the highest one is accepted by ALTRA, followed by DPS, followed by HIGR. Similarly, if you see in the rejected list, the lowest one is ALTRA, or if you see the set that is 11, in 11 data set, what happened? There is no list that are rejected using ALTRA. Right? Like that, you can calculate the performance of the algorithm. Similarly, you can go insisting rescheduling. In least insisting rescheduling, the less one is your ALTRA. So the performance of ALTRA is better in comparison to your IGA and DPS algorithm because very less number of leases are insisting for rescheduling. And if you see how many leases are rescheduled, so you can see the performance of DPS and ALTRA is same. The performance you can see same. In some cases it is zero also, but the performance is same. Okay? So this is all about the resource allocation problem. Next, I will tell you a very interesting problem that is called as your fairness algorithm. So before about this fairness algorithm, just I will tell you a small story, right? So what is the story? The story is that suppose you want to go to a temple, right? And assume that the time in which you want to you have reached, there is a long queue. Okay, there are two queues. One is male queue, another is called as a female queue. In front of the you can say a temple, there is two long of male queue, another is called female queue. Right? So what will happen? What is the policy we need to adopt in order to uh, make the visitor okay go for this worship, right? How they are going to enter to the temple? That is the it's called is the fairness problem. What is the problem here? If you are giving priority to the female queue, then what happen? Very soon the female queue is empty. Okay, but male queue is facing starvation. Okay. On the other hand, if you are giving chance to the male in instead of female, then female is the starvation. So what is the solution? The solution is that one person can say, if the ladies or the female queue is less number of you can do, you take two male and one female, or you take two female and one male. So this is 2:1. Somebody may say that no, I'll go for three, where three may be male and three may be female. So like that, if you generalize, it is n is to 1. Right? But what is the optimal value of n? Come to the technical example. If you are giving priority to the advanced reservation lease, then B will never get a chance because AR is having highest priority in comparison to the best effort. So there is no fairness. It will also list the B leases. So what is the solution? You have to give priority to few B leases. Okay, by rejecting the A to gain interest in the B customer. That's why I'm saying. Therefore, a significant problem is that A or B leases such that the starvation among the leases are reduced up to some extent. We are not saying starvation will completely be reduced. We are saying at least some B leases we are giving so that it will not face starvation. So in order to that, there is an algorithm that is called as your fairness aware calculation. That is called as FATA algorithm. So you can see one example so that the idea is more clear. So this algorithm, why it is from few best effort leases to schedule before the AR leases in a regular interval. However, the interval depends upon the arrival rate of AR. We are going to find the rate of arrival of AR leases, the rate of arrival of the B leases, or male Q or female Q in the non-technical term. So once you calculate the rate, how many people are coming within a time duration, then you can estimate whether to go for 2 is to 1 or 3 is to 1 or 4 is to 1. In general, we can say n is to 1 where n is any number. So for example, if you see, I will tell you an example. At t is equal to 0, assume that there are 8 advanced reservation based effort leaves. Okay, 8 number of advanced reservation leaves is there, 20 number best effort leaves are there. In a normal scenario, what will happen? 8 AR need to be scheduled first, then only 20 B leases will be scheduled. If there is no fairness, you have to go 8 your 20 B leases, which leads to starvation among the best effort leases. So in order to avoid that, what you have to do, you have to perform a new scheduling algorithm. You have to propose or develop a new algorithm which can combat this issue. So here we are representing AR leads in the form of SEN, where S is the start time, E is the execution time, N is the no preemption. You know that advanced reservation is not printed, but B leads can be printed at any point of time. Similarly, if you see the B leads, okay, B leads is represented in the form of ESP. E is the execution time. ST is nothing but a starvation time, or you can say it is some kind of deadline. P is nothing but preemption. So you can print the leads. So if you can see in this particular diagram, at the time t is equal to 0, one best effort leads. What it is asking? It is asking 5 unit of work, 5 time unit of work, and this work need to be assigned. This work need to be assigned before 50th time unit and in the primitive unit. So what we are doing? We have immediately scheduled it here because there are no leases at the time t is equal to 0. But what happened at t is equal to 2? A AR lease is reached to the system which is asking 5 unit of work which need to be started at 2 and it is in the non-primitive mode. So what you have to do? You have to print this best effort and you have to start the work from 2 to 5 unit that will complete by 7. So once the AR is completed, so you have to resume the best effort so that it will complete by 10. So you can say this is 2 plus 3 is 5. But this case, it is AR case it is asking 5, best effort case is also asking 5. But we are giving in two different slots because of the arrival of the advanced reservation leads. Similarly, you can see suppose at of time where this best effort lease is completed 2 plus 1 here, 3 unit of work out of 5 unit of work, another advanced reservation is coming. What you have to do? You have to give priority to advanced reservation. It will continue up to let's say 13. Then again you have to resume the best effort BI. So you can see here there is a preemption, here there is a preemption, and finally it will complete at the 50 minutes of time. Okay. This is the typical scenario or motivational example which says you have to do something for your best effort leases in order to make in order to avoid them to face starvation. So you can see there is a specific algorithm is there. So you can go through this algorithm, right? What you are doing here, first you are checking the queue sites, right? If there is an advanced reservation leads, you are going to add the advanced reservation leads. For example, when AR is reached to your system, just add the counter. This is called as counter of AR. Total number of AR tasks in the waiting queue. And how many tasks are present in the best effort queue. Why you are calculating this one? You want to know that what is the rate of arrival of AR leads and best effort leads. Once you find this count, you can what you can calculate? You can calculate rate of arrival of AR is nothing but in the numerator part is the total number of AR leases divided by total number of AR plus B leases, the denominator, right? And you have to take a threshold that is pi. Okay, sorry, this is tau. You have to take a threshold, and if this tau value is selecting is very difficult. So if the tau value is let's say 0.2, what you are doing? You are going to assign 20% of the leases, B leases prior to the advanced reservation lease. So based upon the scenario, what you are going to do, you have to tau value, right? So after finding this tau value, what you can do, you can take R and R dash. R and R dash is nothing but in what way you are dispatching the advanced reservation and best effort task. Okay, then you have to decide how many AR leases will be system, and after how many AR leases, a B leases will be given as priority in order to avoid the starvation. Okay, this is the long if you calculate, then you will get these values, and you have to continue until unless the waiting queue is empty, right? So what this figures you can see in this figure, the red one indicate the existing algorithm, but if you see the green one represents the proposed algorithm. If you go for the existing algorithm, what it is doing, it is giving priority to advanced reservation leads. You can see if in a particular system, if you assume that total leases, that is best effort leases, is let's say 20%. 20% means out of 512, it is 20%. We have 512 is 20% means it is 51 plus 51, it is 102.4. Okay, okay, it is 51.2, 51.2, so it is 102.4. So 102 number of best effort leases is executed of the schedule, right? So you can see the red one indicates all the advanced reservation leads is completed at this point time. After that, we have started the best effort leads. But in the proposed algorithm, what we are doing, there is no such thing, right? They are also giving priority before the AR leads. So you can say in the green one, it is properly distributed in comparison to the existing, right? So you can also think of one new algorithm. If you are getting any new algorithm, you may contact me so that if your performance is better, then you can write a research article. The last point of discussion, okay, that is called as a posted price model. It is a very interesting model, but the problem here is that we assume that there are six number of tasks that is represented as T1 to T3 up to T6, and there are six number of clouds that is C1 to C6. What you have to do, you have to select a cloud for each task, right? So what happened? We have assessed the performance. What we are doing, we are mapping T1 with C1, T1 with C2, T1 with C3, like we are going on up to T1 of C6. And we generated one value that say in is in between 0 to 1. Okay. Initially we are taking this value randomly, but you can take this value by following a mathematical notation. Right? After knowing this value or after creating this matrix in between the task set and your cloud set, you have to apply the posted price model. What posted price model says? First, you have to apply one of the very popular algorithm of mathematics, that is called as the Hungary algorithm. So, in the posted price model, in order to allocate the resources to the task, one researcher used this algorithm. So, what Hungary algorithm do? Hungary algorithm, the very first step is to subtract the row minimum. You can see this matrix, which one is the row minimum in the first row, which one is minimum? The minimum is 0.23. So once you find the row to do, you have to subtract the row minimum from all other elements that are present in that row, like 0.6 minus 0.23, 0.53 minus 0.23, 0.38 minus 0.23, 0.23 minus 0.23, which leads to 0, 0.96 minus 0.23, 0.96 minus 0.23. So it will result this row. Similarly, you find the minimum of T row. So T2 row, the minimum one is 0. As the minimum one is 0, so the row remains unchanged. The same row see in the second one. Similarly, T3 case, the minimum one is your 0.31. So you have to subtract 0.31 from the third row. Just this particular row. Once you find the subtract row minimum, what you have to do? You have to calculate the column minimum. Second step is your column minimum. You can see in the first column, which one is minimum? The minimum one is 0.11. So if you go for column minimum, 3 and T6 becomes 0. Right? So you can see in the slide, T3 and T6 is 0. Similarly, find the minimum of C2. Minimum of C2 is 0.30, sorry, 0.22. So 0.22 I have to subtract from all the other elements. Okay? So you will get this value here. Once you are calculating the subtract row minimum and subtract column minimum, you cover all the elements that are 0 with minimum number of lines. You have to put minimum number of lines to cover all the 0 elements. So in this case, if you see, 4 line is sufficient to cover all the 0 elements. Okay, while you are covering 0 elements, some non-zero element will also come, but your idea is to cover the 0 element. So how many lines are required? Excuse me. How many lines are required? 4 lines are required. So if number of lines is equal to number of rows, then you have to stop. But in this case, what happened? The number of lines is 4 and number of rows is 6. As number of lines are 4 and number of rows are not same, what you have to do? You have to find the minimum uncovered element. Minimum uncovered element, covered element. For example, you remove these values, which one is covered using line. After removing this, check which one is not covered. Out of this uncovered element, which one is lowest one? So you can say 0.08 is the lowest one out of all the uncovered elements. So if you, after finding this minimum uncovered element, what you have to do? You have to add this value to the covered element. Covered element means the line element. So you can see this 0 will become 0.08. But what about this point? This element is covered twice. As this element is covered twice, what you can do? You have to add 2 times 0.08. So if you see here, this value is added 2 times 0.08, which is the minimum uncovered element. Similarly, in this case also you can see there is an overlap. You can see there is an overlap. Two lines are intersecting each other. That's why we are adding 0.08. Okay. After finding this one, what you have to do? You have to again find the minimum element. In this matrix, you have to find the minimum element is 0.08. What you have to do? You have to subtract this minimum element 0.08 from all the values. If you remove, then if you subtract, then you will get this value. Okay, after finding the minimum element, that is 0.08, what you are going to do? This minimum element you have to subtract from every element in the matrix. Once you done this, what you have to do, you have to again put lines to check whether number of lines is equal to number of rows. So in this case, you can see the number of lines is 6 and number of rows is also 6. This is the first line, second line, third, fourth, fifth. This vertical one is the sixth one. If not, then you have to iterate this process until unless number of lines is equal to number of rows. Okay. After that, what you can do, you can see this one indicates the appropriate allocation of the cloud to the resources, that is your task. Okay, or the customer. Customer is assigned with a particular cloud, and you can see there is no overlap. T1 is assigned to C2, so no other task will be assigned to C2. T2 is assigned to C4, no other task is assigned to C4. T3 to C1, T4 to C5, T5 to C3, and T6 to C6. And if you calculate this Hungary algorithm, you will see that your result is same as your optimal allocation. That's why Hungary algorithm is popularly used in posted price model. Last slide, just I will tell about this one. This is called as your allocation aware scheduling. So I told you, whenever you go for a multi-cloud environment, or we discussed about inter-resource management, one cloud is taking help of another cloud in order to satisfy the requirement of the customer. So what happens in that case? There is a centralized unit is required, which monitors all the resources that are present in various cloud service providers. You can see in the bottom part, there are a lot of customers are there. So these customers are requesting the cloud resources through a broker. And decide which cloud is free, which cloud is busy. This is possible because of the standard SLA if you prepare, or standard API or standard library, then only this allocation aware scheduling is possible. So what happened? The way the cloud broker is assigning the work to the different clouds, in that way order, if you see, and if you see the order in which the cloud is going to assign the resources is different. What I want to mean here, the scheduling algorithm which is used in the cloud broker is different from the scheduling algorithm which is used by the cloud. You may think the resource one is best for you, but once the resource is given from cloud broker to the cloud service, what happens? They will have their own scheduler. The scheduler may assign to some other resources. So your latency will be increased. So in order to avoid that, you need collaboration of the multiple cloud, so that after dispatching the task from the cloud worker, the cloud scheduler can take a decision that which resources is best for individual customers. So this is a highlight only. So this is called as your based upon the allocation. You have to see what kind of scheduling algorithms are used by the cloud, because they may use different scheduling algorithms. One may use round robin, another may use FCFS, another may use shortest job first kind of thing, another may go for the least scheduling, another may go for the backfilling algorithm. So their values may be, their scheduling algorithm may be different. So in order to combat this issue, you have to aware that what kind of allocation is done by the cloud broker as well as the scheduler, and you have to map them properly so that appropriate resources can be found for each and every individual customer.